Hello everyone, welcome back to another video. I hope you're doing good. Now, today in this video, I will be simulating a very famous solution for this 100 prisoners problem in Python basically. So first I will go by explaining the problem, its solution. Then I will go to the simulation of our code, and then we'll see some basic visualizations of our results. And then I'll conclude this video. Now here's the problem. There are 100 prisoners, each labeled from 1 to 100. They have their own unique number, that is from 1 to 100. All right. They go one by one into a room with 100 boxes. Now, the 100 boxes are also uniquely labeled from 1 to 100. And inside each box, we find a number that is also unique from 1 to 100. There are 100 boxes, and inside each of the box, there is some number. Okay. Now, a box may contain any number from 1 to 100. Each prisoner is allowed to go into the room and open up to 50 boxes in order to find his number. So if he is able to find his number, then he succeeds, else he fails. But to win this game, the condition here is that all the 100 prisoners should succeed in finding their numbers. All right. Now, they are allowed to discuss any strategy before the game begins, but after the game starts, nobody is allowed to communicate with each other in any forms. So now we come to the solution part. Now, first, I will just explain the simple ordinary solution. This is also called as simple random selection. Now, what happens is in this is that a prisoner will go into the room and randomly select and open up to 50 boxes to find his number. Now, here the probability that a prisoner will find his number is 50%. And the probability that all of the 100 prisoners find their number is just 1 by 2 multiplied by 1 by 2 multiplied by up to 100 times. Now, because they are all independent from each other, so we can just multiply their individual probabilities. Now, this gives us a very small number. You can see on the screen, it's a very small number. Now, this number is almost like there is no chance for them to win this game. Now, I won't go very deep into the mathematical formulation of the solution. This is not the agenda for this video. So now we come to this very famous solution. This is a loop following strategy. Now in this, the prisoner enters the room. He starts by opening the box which has his number on it. He opens the box and finds some number, and he goes to that box number, opens it and finds another number. Now he keeps on doing this, repeating this until he has found his number inside the box, or he has opened up to 50 boxes. Now, so by this strategy, he is guaranteed to be on the loop that contains the box with his number inside it. Now here the success depends on whether that loop contains more than 50 boxes or not. So there can be many loops in some arrangement. Now the probability of their success is simply the probability that there is no loop with the boxes greater than 50. Now if we follow this strategy, then we get a probability of close to 31%. So this is very huge compared to what we saw in the previous strategy. So here is this code for simulating the solution. I have just imported few important libraries here. So I've created a function, and this function does the simulation. Like here we have the 100 people. Like for all the 100 prisoners, I am doing this loop kind of thing. Where each of them gets 50 chances to open the box. If they find the box, then they succeed, and we just keep incrementing the counter. And if it doesn't found, then we just try to index the array that we created for the game, and then we have shuffled this. It's just a random shuffling. This feature in Python allow us to do this thing. Yeah. Now in the end, we just count how many of the game they won and how many total game they played. So it gives us the ratio or the percentage, the win percentage. So this is the task of this function, and this function, it just calls this function, the function that we defined here, as many number of times we want. So we are just basically this is to create the many number of such samples. Okay, and this returns in the end array basically with all the percentage of wins that we get. Okay, so let's run this code. We'll see how much time it takes. Okay, so now as you can see that it took us around 13 minutes to execute this code. So, okay, so let's check what we got here in the samples. You can see these are the values that we got, and you can see that it is very close to 31. So yeah, it has approximated very well. Okay, so these are the values that we have got. Now these, you can see that they are very close to the calculated value that was 31. You can see these values. Okay, so just let plot a simple histogram for these values and see. Okay, so here you can see that we have plotted the histogram. It's kind of a distribution, how our values are distributed. So you can see that most of the values approximately lies between somewhere between 29 and 33. So this is the range where most of the values lie. Okay, we have plotted this quantile plot just to see how it resembles a normal distribution. So yes, this distribution resembles quite well to a normal distribution. So this is the conclusion that we get. Now these random simulations in Python are very useful because they save our time and effort to simulate these random processes. So we saw that how the our experimental results match the theoretical calculation. Now, why does it happens in this strategy? Maybe because now the selection of boxes is no longer random. We are actually selecting the other box based on the number inside previous box. So maybe because this is biased in some kind of way, we are getting this interestingly very different result. So this is all for this video. We have made it to the end. Thank you for watching this, and I'll see you in the next video.